Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're going to be going into a 12th grade topic, finding derivative using the quotient rule. So in our first part of our video, we'll be talking about what the quotient rule is and when you would need it. And in the second part, we're going to use the quotient rule to find the answer to our question for today. Remember, if you have any questions about what you see today, feel free to put them in the comment box below or visit me on Facebook at Tutor Me Senpai. You can always tell me about your homework there as well if you want to see your homework on this channel. If you find this video helpful, remember to leave a like, and while you're at it, hit the subscribe button and the notification bell so you know exactly when I drop my next videos. Well, without further ado, let's talk a little bit more about the quotient rule. So before talking about the quotient rule itself, we got to figure out when the quotient rule is applicable. We can't just use the quotient rule on everything, so in what form does our function need to be in order for us to be able to use the quotient rule? So let's say we have a function f of x equals a g of x over an h of x. So in this case, we have a function that's really made up of two different functions in fraction form. This is exactly what the quotient rule was made for. If you have a function that looks like this, don't even hesitate, you're going to use the quotient rule. So let's say we were trying to find our derivative f prime of x. The quotient rule will tell us to do the following. We're going to take our denominator, h of x, and multiply by the derivative of the numerator, g prime of x. Then we're going to subtract the product of the numerator with the derivative of the denominator. So it's going to be the numerator be g of x times the derivative of the denominator, all over the denominator squared. So once again, finding the derivative of f of x, our f prime of x, according to the quotient rule, is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. This is your quotient rule. If you can remember this, simply find your four parts, your g of x, your h of x, your g prime of x, and your h prime of x, and you can plug everything in and simplify, and then your work will be done. So let's say your memory is as bad as mine. Remembering that off bat is going to be a little bit more difficult than you would like it to be. So let's look at some ways to kind of help you remember. So let's say you have a function, and I'm going to use the notation y of f of x over g of x to kind of drive home a point. If you have a function like this, you know you can use the quotient rule. However, I want you to look at the parts of this function, right? You have a function in the high part and the function in the low part. The high part being the numerator, the low part being the denominator, right? So if this is your high part and this is your low part, we can actually construct the quotient rule using these highs and lows. And that's, once again, just letting you know what function you're supposed to be looking at, whether the high function, the numerator, or the low function, the denominator. So we can rewrite this dy dx to be the following. Well, we're going to keep whatever's in the denominator the same, right? We're going to keep that low. But instead of just having one, I want you to write that twice. Low, low. All right? We're all over low, low. Next, I want you to write another low first. So if you have low lows in the bottom, you write your first low up top. Next, write a little multiplication sign. That's important. So it's low, then your multiplication sign. Then you're going to write this d here. And this d is going to be similar to that d. This d is letting you know we're going to do a derivative. So if you want, you can even make this a lowercase d to really drive home the point that this d and that d are telling us to do the same thing. And then we're going to put high. So low times d high. Then we're going to do our subtraction. And then we're going to do our high with our multiplication sign again. Put another d. And we're going to put our low. And you can read this as low d high minus high d low all over low low. If you can remember this, this will be the kind of roadmap to lead directly into the quotient rule by substituting what high is, what low is, and their respective derivatives. So once again, low d high minus high d low all over low low. And this low low is really just multiplication, or low squared. So our example for today has us looking at an f of x equaling x cubed all over 3x plus 5. And once again, first thing you should do whenever you're trying to find a derivative is figure out which rules you're going to be using. This is going to be definitely using the quotient rule because we have a fraction with a function in the top and a function in the denominator. But there are sometimes we have to use multiple rules. So in this case, we're going to be using the power rule as well. So if you haven't seen my video on the power rule, I recommend you pause this one just for a little while, check that one out really quickly, and come back because we're going to be using the power rule in conjunction with this quotient rule. So going back to our function for today, we're going to rewrite this in general terms, and we're going to give the top a function of g of x, and the bottom the function of h of x. That way we can simply plug and chug what our g of x is, our h of x is, and their respective derivatives. So g of x in this case is going to be x cubed. H of x is going to be 3x plus 5. Now, according to the power rule, our g prime of x is going to be 3x squared. Our h prime of x is going to be 3. So now that we have our four components, let's use our lows and highs to derive our quotient rule and then ultimately plug this in to find our answer. So remember, f prime of x is going to have a low, right? And while you're at it, let's put another low. So we have a low low. And then while you're at that, let's put our third low up top. Put our multiplication, put our d, put our high, our subtraction, put our high again, our d, don't forget that multiplication, and then our low, right? Low d high minus high d low all over low low. And we already talked about lows and highs, right? This is high, this is low, and these d's tell us to use or find the derivative. So now let's plug in what we have. So let's simply replace these with their respective functions. So if that low was this, we're going to plug it in. So that's going to be a 3x plus 5. Our d high is going to be our derivative of the top, which is g prime of x. So this 3x squared. So we're going to substitute our 3x squared here, minus our high, which is just this x cubed, right? So our g of x. So we're going to put that in here. X cubed. And our d low is going to be a derivative of h of x, which is h prime of x, which is simply, in this case, 3. All over low low. We're going to rewrite that as low squared, so we don't have to necessarily factor everything out. But our low is h of x, which is once again 3x plus 5 all squared. So when we expand this out a little bit, we have our 3x squared times 3x, which gives us a 9x cubed, plus 3x squared times 5 plus 15x squared minus a 3x cubed all over, and we'll just leave this as 3x plus 5 squared. And you see we have a 9x cubed here and a 3x cubed. So let's combine that to simplify this just a little bit further. 9x cubed minus 3x leaves you with a 6x cubed plus 15x squared all over 3x plus 5 squared. And that is our answer for today. 6x cubed plus 15x squared all over 3x plus 5 all squared. So remember, if you have any questions about what you saw today, feel free to put them in the comment box below. Don't forget that low D high minus high D low all over low low. If you found this video helpful, remember to leave that like. It really helps the channel. Also, while you're at it, smash that subscribe button and ring the notification bell so you know exactly when I drop my next videos. If you want to see your own homework on this channel, feel free to visit me on Facebook at Tutor Me Sempai and tell me all about it there. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.